Okay, this is a quick review of 9.1 and 9.2. It's a formative quiz on solving inequalities, specifically how to graph inequalities and how to solve one-step inequalities. So your first question is true or false, and it says 4 is less than or equal to all values when represented graphically. So the first thing I want to say is, if you were given this inequality, it's easiest to start at your variable and read backwards. So when I read this, I'm going to start at my x value, which I'm going to read as all values, right? So the x is going to be all values. And since I said all values, and this is eating what I said, and I'm reading it backwards, all values greater than or equal to 4. So when I read that, it's going to be all values greater than or equal to 4. And when I look at this graphically, it's a closed boundary point, and it does show that all values greater than or equal to 4. So the answer for this is true. The second question says open boundary points do not include the point they are on. This is true. Open boundary points do that, and closed boundary points do include the point they are on. Question 3, all values less than 6 is expressed algebraically as x is greater than 6, and this is, of course, is false, because any values less than, all values is represented by x, is less than, since I said all values is less than does not eat what I said, less than 6 would be this instead of the other, so it's false. The next question says the value of x minus 4 is greater than 5 is the same thing as saying the value of x is greater than 9, and the answer for this is true, because if I take this expression and I simplify by adding 4 to both sides, I would get all values greater than 9, which is what this says here, so it is in fact a true statement. Question 5 says negative 2x is less than or equal to 10, which is the same thing as all values less than or equal to negative 5. So if I take this equation right here, this part right here, and I expand it by dividing both sides by negative 2, I would take x, but I have to flip my sign because I divided both sides by negative 2. And here I would have, I'd have negative 5. And since this and this are not the same thing, the answer for question 5 is false. They are not the same thing. Because when you divide by negative 2, you must flip your inequality sign. Question 6, negative 2 times the value of x minus 5 must be less than the value of 10. When this is represented graphically, it looks like this. So the first thing we're going to do is make this a little bit bigger so we can actually see it. But then we're going to take our equation and we're going to isolate the variable by adding 5 to both sides. Negative 2x is less than 15. And we're going to divide both sides by negative 2. And again, when we divide by negative 2, we flip our inequality sign. And we have any value that is greater than negative 7.5, but does not include 7.5. That's what this line is saying. So therefore, the solution is true. Graph the statement all values less than or equal to 5. All values less than or equal to 5 numerically looks like that. And when graphed, I told somebody, make sure you put whatever value it is in the middle. This would be 6 and this would be 4. So since this part here is included in it, it's a closed boundary point because the value has to be equal to or less than. And all values less than or equal to 5 would be this way on my number line. The next question, graph the statement all values greater than or equal to 2.5. So all values greater than or equal to 2.5. And you could write it like 2.5. Either one's fine. So on my number line, I'm going to make this 2.5. I'm going to make this, you can make it 2.6, you can make it 3. Probably more appropriate with 3 and 2. And since this is here, it's a closed boundary point. And all values greater than or equal to 2.5 would have my number line going this way. All values less than 0. All values less than 0. So I'm going to put 0 here. I'm going to put negative 1 here. I'm going to put 1 here. And all values, it's an open boundary point because it does not include it. Less than 0 would be this way on my number line. graph the statement all values greater than 1. All values greater than 1 and 2/5. So here on your number line, uh, it's not really complicated. Make your middle one 1 and 2/5. Now since that's 1 and 2/5, it seems logical this would be 1 and 3/5, and this would be 1 and 1/5. But you could have had whatever you wanted there. But that makes the most sense to me. That way the spacing here actually represents a fifth. So it just logically works, but you could have done whatever you want. It's up to you. All values greater than, so it's an open boundary point, and greater goes this way here. Interpret with an algebraic inequality statement. So this says all values less than or equal to, because it's a closed boundary point, -10. So any value that's less than or equal to -10 is what that line is representing. Your next question, this is all values that is greater than, but not equal to, because it's open boundary point, 4. All values greater than, but not equal to 4. All values, and since that is less than, but not equal to, and since it's midway between 2 and 3, we're going to say 2.5, or you could say 2.5, it's up to you. All values less than 2.5. All values greater than or equal to, because it's a closed boundary point. And what would be between 0 and 0.5? The answer is 0.25. So any number that's greater than or equal to 0.25 would be included on that number line. In order for me to graph the next question, 2x is less than 10, I first have to isolate for x by dividing both sides by 2. X is less than -5. It's not equal to, so it's an open boundary point. I'll put -5 here, -6 here, and -4 there. Make sure you don't put -4 down here accidentally, because that's not where it goes. It's -6 there. And any value less than -5 would push my number line this way. Again, here we have a good, we're going to divide both sides by -2 to isolate. And when we do that, we get x. But because we divided by a negative integer, we have to flip our inequality sign. -6 divided by -2 is 3. So our solution is now all values greater than or equal to 3. I put 3 there and 4 there and 2 there. It's greater than or equal to, which is a closed boundary point. And our number line goes this way. Any value greater than or equal to 3. Your next solution says, or next equation says all values -1.5 is less than -1.5. I'm going to add 1.5 to both sides to get rid of your constant. All values less than, the sum of -2.5 and 1.5 is -1. So all values less than -1, make -1 there, and 0 there, and -2 there. Open boundary point, because it does not include -1. And all values less than -1, make this the solution. Next question says all values plus 1.25, it has to be greater than or equal to -0.25. Isolate by getting rid of the constant. All values greater than or equal to, the sum of those two is -1.5. So all values greater than 1.5, -1.5 goes there, -1 goes there, and -2 goes there. Some people have a difficult time with that. All values greater than or equal to is a closed boundary point. And all the values that way would be greater than or equal to -1.5. Okay. Your second last question says 10x plus 4 is greater than or equal to -8, which is actually a two-step equation, which is actually from 2.3, but that's okay. So I'm going to subtract 4 from both sides. I get 10x is greater than or equal to -12. Divide both sides by 10, and I get x is greater than or equal to -1.2. Now pay attention how we graph this. So what we're going to do is I'm going to put -1.2 here. I'm going to put -1.1 there, and -1.3 over here. Since it's greater than or equal to, it's a closed boundary point, and greater than or equal to 1.2, -1.2, goes this way. And our last equation, our last expression, our last inequality is x. All numbers divided by negative 2 plus 1 have to have a value less than or equal to 0.5. I'm going to subtract 1 from both sides to get x divided by negative 2 is less than or equal to negative 0.5. The sum of a half and a negative 1 is negative 0.5. I'm then going to multiply both sides by negative 2. And because I multiplied by a negative, I must flip my sign. And a negative half times negative 2 is positive 1. And therefore, all values greater than or equal to 1, 1, 2, and 0. Close boundary point. And all values greater than 1 are included.